Okay, well, I'm going to get started. Thanks, everybody, for coming. My name's Petervan Hardenberg. I'm team lead on the Heroku Postgres project. We've got 20 minutes. Let's go. So I'm going to quickly go over the first question that probably some of you are asking, which is, what's a Heroku? The second question is, what's a Postgres service, and why did you build one? And then the third one is, what exactly do you do anyway? So what's a Heroku? Heroku is a platform as a service. That means we're an alternative to running servers. If you think about basically the internet as a layer cake supply chain, at the very bottom you have hardware providers that are selling to infrastructure services. Then on top of that you have infrastructure services. VMware, I think, provides some of this material. Amazon certainly provides a really excellent service they've built on top of Zen. There are lots of other people in the space. They provide virtualized servers. Heroku's basic thesis is that virtualized servers are still too much administration work to actually use daily. So what we do is we provide an extra layer on top of that where we take your code and we run it for you. We do all the work. So what we offer, the main product, is a powerful stateless runtime. And that means that if you give us your code and a server that it's running on gets hit by a gamma ray, we can just spin up another server somewhere else. Our routing infrastructure self-heals, routes the requests around it. If you go from getting 1 hit a minute to 100 hits a second, we can just scale out. You type one command into a command line, you have 100 servers running in seconds. When you don't want them anymore, you throw them away. Totally, totally effortless. So we also offer a really simple deployment mechanism, which is Git version control based. And we officially support on the runtime Ruby, which is where we got our start, Node.js, because we thought it had an interesting use case, Clojure, because we have a Clojure guy. Clojure is a cool language, but now we support Java, and as of yesterday, we've announced Python support. It's currently officially in beta, but we've been using it in production for a long time, so please feel free to give it a try. Okay, so quick demo just to show how it works. This is my talk. Here it is. Can anyone see that okay? So I'm going to do a Heroku create PG open 11 talk. So this sends a message to our API which says, hey, I need an application. Let's make that even bigger. Okay, so now I'm in a Git repository here. Let's see if I'm up to date. Yeah, I'm good. So we've got this Git remote. I'm going to take this and say git push that master. So there we go. We're sending the code. Heroku receives the push. Gets set up. And I'm just going to prime here by going to, what do I call it? PG open 11 talk.heroku.com. Ruby Gems is so slow these days. Oh, come on, you're killing me. I've only got 20 minutes, guys.
I was just thinking you're a brave man to a live demo.
Heroku is fast. Ruby Gems I'm not as impressed with these days. Come on. Okay, there we go. I hear ops in the back there. And we install all the dependencies. And we're live. So now if I go here, here's my talk. So we run 4. So there we go. So that's Heroku. If you want to make changes, you just edit your code, push it up, it's good to go. We use this in production all the time. We run our parts of our service on Heroku, or Heroku is increasingly self-hosted. We believe this is the best way to build a better service. I've done, with our team, about 1,000 deploys in the last year, and we have effortless scale, as I described. I'm not going to get too much into that because I'm the database guy. So maybe you're wondering here, if if I'm just pushing code and everything's stateless, where's the data, Lebowski? It's pushed down just to a lower place in the stack. So Heroku's great. It's this amazing stateless runtime, but we needed a place to keep data, and that's where Heroku Postgres came from. It's a production database service. We have the most Postgres databases in the world. I looked just now. We're running let's see here, about 185,000. This is a live counter. And a significant fraction of those are actual real production apps. So how does Heroku work? Basically, we have a front end that routes web traffic down to dynos, which are these stateless runtimes. And then we push that down. All your logs get pushed out and aggregated into a single stream and then sent back to you. And we have an add-on API where we can plug in things like databases, queuing services, asset stores, and so on and so forth. And basically, what we offer is just a database add-on, because we thought that people doing stuff like Mongo and CouchDB and all these kind of things were great, but at some point you really need to ship. So here's the Heroku Postgres site. You can check it out. We've been in production for 4 years. We've recently opened it up to all users. The Heroku Postgres service we announced recently, which page is here, this actually this is the same service we've been running forever. We just made a nice interface to it. So we weren't really happy with what was out there when we started this project. There are other people doing database services, for example, RDS. But we felt that they really had the wrong philosophy. RDS is fundamentally about servers. You get an RDS server, Amazon provisions this thing for you, installs MySQL on it. That's not what you want as a developer. What you want is a database. You don't care about servers, and you shouldn't, right? And the role of a service is to make sure that the database that you've got is always there, it's always working, and you don't have to think about it. That's what we try and do. So the next question is always, well, why Postgres? And the answer is obvious. Postgres is totally awesome. It's incredibly stable. It's the best open source SQL database in the world. I had to add open source because somebody complained that Oracle is actually quite good if you're willing to put up with it. No SQL solutions out there are all specialized and or immature. And we have a strong, diverse community, which means that we're resistant to acquisitions, unlike certain open source databases we could mention. The conclusion, of course, is Postgres is awesome. Just a few highlights, things we really like about Postgres. Wall shipping, streaming replication, and sync rep. This gives us an amazing durability story. We ship everything we do out to a multi-data center storage service, which gives us unbelievable data security. We love the data types. We use HStore for all kinds of things internally. The temporal data types are really great. PostGIS is a really cool project. Nobody else can touch it. There's nothing like it out there. The new hotness that's coming out these days is amazing. SQL Med, I think, is going to be really big. What's going on with extensions in 9.1 and hopefully 9.2 and 9.3 and going forward, and PGXN, totally awesome. Programming language, procedural languages. And I want to do a brief aside here just to call everybody's attention, as I have throughout this conference, to PLv8. This is a V8 JavaScript engine language. It's from NTT. I see Koichi there. Thanks for coming. We really appreciate you guys building this. It's a trusted language, so you can deploy it without worrying that if you don't escape your strings right, that someone is going to go start monkeying around as the Postgres user inside your cluster. And it's JIT compiled, which means that it's fast and you can actually write real stuff in it. I think that PLv8 is probably the most exciting thing that nobody's heard about in Postgres. So now you know. Okay, so now let's actually look at what the service is and what it does. So basically our idea is you should write your app, write the code. We do everything else. Who's it for? Developers of web applications. Basically, in database terms, we serve pretty well OLTP loads for less than 1 node, or less than 1 terabyte per node. If you have a sharding strategy that keeps your nodes under 1 terabyte, we can probably work with you. It helps if you're in or near AWS. That's currently where all our servers are located. We expect to be expanding beyond there before too long. And it's really for people who prefer not to manage databases. Okay, now, I know that many of the people in the audience here, I've talked to you, I know you now from past conferences. This isn't for your personal project. We don't give you super user on the cluster. This is about providing a service that you can't shoot yourself in the foot with as much as possible, and building that up to be reliable and robust and well-tooled and easy to work with. Here's a good example customer, GroupMe. They're an ad hoc communications group that works over SMS or a phone app. They're perfect for ski trip messaging. You go with a bunch of random people, to the mountain. Hey, who wants to grab lunch? You're at somewhere, a conference or something with some coworkers. You put together a little group. You can find them. It's a great service. I used it for ages before I found out that we hosted them. Then I found out that we were running their database, and I was really happy. They just got bought by Skype for $80 million, which is really cool. And if you haven't used them here, this is what GroupMe looks like through the web interface. You'll have to imagine the phone. So another customer that I'm really fond of is Reportive, which I describe as Terminator vision for your inbox. If you remember that scene at the beginning of Terminator where he's looking at people and it's popping up all the little information, it's like that for Gmail. Wrong button again. So what it does is it adds a sidebar to your Gmail that basically is pulling in information from all kinds of different sources like Twitter, Facebook, LinkedIn, Skype, etc., public profile information. And they just have feelers out all over the internet pulling in information from publicly available sources and then aggregating that into little profiles. So when you mouse over somebody's name in Gmail on a thread, you can see a picture of who it was, you can see what they've been tweeting about, you can see where they are and who they work. This has made it much easier for me not to embarrass myself on the internet. And if you're not running it, it's free and totally useful, and I highly recommend it. So those are my plugs there for those guys. How am I doing on time here?
7 minutes.
Oh, good. 7 in or 7 left? Okay, good. We're doing all right. So our main focus is always on, I shouldn't say main focus. The one thing I think that we focus on that very few other people do is improving developer productivity as a primary activity. So for example, we provide immediate provisioning, right? You go to our website, you go log into the service, you click the plus button, you have a database running. Small database, giant production database, it's there in a minute. Our average provision time is about 60 seconds right now. We're working on bringing that down. We want people to be able to create databases, use them for 10 minutes, and throw them away. Even if it's a massive, giant instance, we're fine with that. We believe that you should just be able to get databases on demand instantly. We have good tooling around SQL import-export. With a single, much easier command than pgdump, you can pull a SQL source in off the internet, load it into your database, or take a backup and push it out, even if you have a very large data set. We have lots of different plans for different needs. We're focused mostly on production sites. Our smallest plan has about 1.5 gigs of RAM. Our largest plan has about 70 gigs of RAM. CPU scales sort of commensurately. And we offer secure database ingress, so you can still use all the tools you need and the ones that you're used to. And we have a simple command line interface as well as a simple web interface for actually doing these things. There's not a lot of knobs. There's not a lot of switches. We think that tools should be out of your way and give you the things you need. So our service, there's nothing to install, works with everything. We ship real Postgres. To me, this is really important as a philosophical position. We don't fork Postgres. We don't change Postgres. We ship Postgres. If it works on your computer, if it works on a server somewhere else, and you're running the same version of Postgres we run, it will work on our service. It's very simple. No asterisks. Now, the day may come when we have to compromise on that, but I'm going to fight that as hard as I can, and if we ever have to wander away, I'm going to work as hard as I can to bring us back. And just from a transparency perspective, we do gather up your logs and send them somewhere. On the Sleep Easy front, we monitor the service around the clock. This means that it's a truly managed service. If your database goes down, it's our responsibility to bring it up, not yours. We have 24/7, 365 on call. I'm actually carrying the backup pager right now. Outages are quickly resolved, usually in less than 15 minutes for a full hardware failure. In the event of a really big problem, we escalate to our core data team, and we can reconstruct. We've seen most anything at this point. Our defense in depth strategy is we have redundant disks on the instances. We can perform hardware migration in minutes. We have automated daily SQL backups behind the scenes and available to the user. We practice continuous archiving at minute intervals out to S3, which is our multi-data center data store. And all that stuff is archived to multiple data centers, which gives us a durability story that I think is basically unmatched anywhere. And we pretty much don't talk about it, and I don't really know why. On our productivity front, we have two really interesting features. We have follow, which basically is a single command line switch you can add to your provisioning, or just a button in our web interface. I think I have one up here. So here's a database, and I can just, I think this one has a follower, which is why I picked it. No, it doesn't. So if I just click this plus button, oh, you can't see that, hang on. If I click this button here and say, okay, make me a Ronin add. So now this is going off, and it's doing everything it needs to create a streaming replica. When people tell you that Postgres replication is easy to set up, I don't think they usually mean this, but this is what easy means. This is what easy means. Everything else is relative, I suppose. So there's lots of cool use cases for this. We have people who use this for read capacity. So for example, if you have a large data set, but your write bandwidth doesn't exceed what a single node can do, you can create a whole bunch of these things and then basically home particular subsets of your data to particular hosts in order to keep as much in hot memory as possible. It also provides an awesome safe analytics host. If you have a database and you just want to run some really gnarly query on it, just create a big follower. Right? You can just say, oh, give me a massive database. I'm going to pull the whole thing into RAM. I'm going to crunch on it for 2-3 hours. When I'm done, I'm going to throw it away. You only pay for what you've used. This also gives you the ability to do small outage window host migration. So if you want to move from a hot database, but you're feeling kind of loaded down to a larger plan, you can bring up a follower and then fail across with it very quickly. This means you don't have to wait for a full dump restore cycle. You don't have to wait for indexes to rebuild. You don't have to wait for the hint bits to get regenerated. You get a byte-for-byte copy. That one really bites a lot of people in the ass, especially on EBS. The other cool productivity we have, we call fork. Fork is cloning on demand. So you've got a data set. You've got some migration. It works in your test environment. You think it'll work in production. You're pretty confident. You're ready to throw the switch. Why not just make a fork? It gives you a byte-for-byte copy. It uses basically the same technology behind the scenes. But what it does is it gives you another database running your exact data set right now. You just go run your migration against that. You poke around, make sure everything looks okay. All right, bring up the new one. Or heck, if you are willing to take an outage window, you can keep the old one around after you do the migration until you're confident that it worked. Also good for performance testing. What size plan should I use? I don't know. Just go make one of each and see what's fast for you. No big deal. You know, it'll cost you $1. Migration tests I mentioned, also useful for staging servers. You just, you know, you've got your database and you want to do something in staging and experiment, just fork it. No big deal. So the secret sauce behind this is Wally. Dan Farina is probably still asleep since I don't see him here. We're from the West Coast. And we've open sourced this. It's basically a little bit like OmniPeter, but specialized to work in an environment where you have a slow per key object store. So it's backed on S3, but we're working on pluggable storage for that. Dan is actually giving a talk about all the tech behind that, so check him out. And features we have coming soon and in beta. We have pilot project support for PostGres. HStore, which we use internally for everything. It's awesome. And PG Crypto. If there are other contrib modules people are interested in or things that people are really excited about, drop me a line, send me an email. I'm really excited about what's happening with extensions, and I'm basically trying to make it as easy as possible for people to adopt this stuff. Even though it's going to be a huge pain in the ass for the next little while, I think it's important for the Postgres project to get there. And because we're big, I think it's important for us to support it, or we'll basically be drag on that. 9.1 is rolling out very soon, I hope. We'll do it as an option at first, and then we'll just shift all new databases over to it. And the other thing that we want to improve is our support for tiny, inexpensive databases. Right now, our smallest plan still has 1.5 GB of RAM, which is overkill if you want to run a blog or just something tiny to play with that's not really going to ever get very big. So I don't know where my fin slide is, but that, as they say, is that. So thank you all for coming. Does anybody have any questions? Am I out of time, or are we good?
The next talk starts in 4 minutes.
4 minutes. All right. If you have any questions, you should probably come see me at the back.